Good morning, everyone. Today we will be finishing or continuing doing the last chapter of the curriculums, which is the chemical calculations. So let's begin. Calculation of or calculating the number of moles. So the number of moles could be calculated by doing the number of unknown substance and number of unknown or known substance. So the number of moles means that we need to know like how many of this substance could be reacted with that substance in order to like end up with like 3 or 4 or 5, for instance, moles of a compound. So we will explore that in a bit. Now, let's take an example right here, and doing that example or through that example, we will be able to know what we are doing. So for the following reaction, we have 2Na plus 2 moles of water as a liquid gives us 2NaOH plus hydrogen gas. So I want to calculate the number of moles of hydrogen, okay, produced, okay, and then I want to calculate the moles of H2O required or necessary to produce 0.75 moles of NaOH. Okay, these are the requirements. So let's begin. So what's known here is the 0.75 moles of NaOH. It's given, and 0.145 moles of Na. Okay. Now, the unknown is the moles of H2O and H2, the hydrogen gas and the water. Now, what we are going to do here is that we will be dividing the number of moles of sodium, which is the known, over the number of moles of the hydrogen, which is the unknown, as is mentioned right here. Okay. Now, this is like from the equation. If we want to calculate a number of moles of like this substance by depending on the number of moles of a known substance, here's what we do. So I will be depending on the number of moles of sodium, which is given, okay, to calculate the number of moles of hydrogen, which is the unknown, the missing one. So 0.145 is known, okay, of sodium times 1 mole of hydrogen. This is from the equation. How many moles? So we got nothing here, right here. Let me just highlight it. So there is nothing right here, which means it's 1 mole of hydrogen. And we have how many moles of sodium in the equation? We have 2 moles in the reacting side. So it's 2 moles, and here we have 2 moles equals 1 over 2 is 0.5 times 0.145 moles gives us 0.072 moles of hydrogen. So this is the first requirement, the number of moles of hydrogen. Now, for the second one, what we are going to do here is that we will be depending on the number of moles of NaOH, okay, to calculate the number of moles of the water. The same aspect, the same method, and we got like 0.75, which is the number of moles of NaOH, times 2, which is the number of moles of H2O in the equation, okay, and 2 moles of the NaOH, sodium hydroxide, which is also given in the equation above. So we got 0.75 moles of H2O. So it's simple. Like depending on a number of moles of a substance, we will be able to like get or find out the number of moles of a missing substance. Now let's explore more. So example 3.2, sodium chloride and NaCl is formed from the reaction of sodium metal and chlorine gas as in the following equation. So 2Na plus Cl2 gives us 2NaCl as a solid, as a table salt. So if 3.4 moles of Cl2 reacts with the enough sodium, okay, what is the number of moles of the produced NaCl? So this is the missing, right? And we got 3.4 of Cl2. We got this one. So what we are going to do here is that we will be depending or using the number of moles of chlorine, which is the known, to get the number of moles of NaCl, which is the missing. So the same thing, 3.4 is given right here, okay, which is this one of Cl2 times 2 moles of NaCl. This is the missing. So the number of moles, of like a known times the moles from the equations, like the numbers before, like like an element or a compound or a substance, the number that is before the substance, which is right here, okay. So for the NaCl it's 2, so the missing over the known, 2 moles over this chlorine, there is nothing here, which is 1 over 1 equals 6.8 moles of NaCl. Okay, here's the number of moles of NaCl. Now, example 3. How many moles of Na2O can be obtained from the reaction of 4.8 moles of sodium according to the following reaction? So we have these reactions, and the missing here is the number of moles of Na2O, the products, and we got the number of moles of the reaction. Sodium is known, so I will be using sodium to get the Na2O, sodium oxide, from like the known substance. So it's easy, it's simple, so you go directly to the final steps, okay. So number of moles of sodium is 4.8 times number of moles of the missing, which is Na2O, which is 2 right here, and how many moles in the equation, which is 4. It's 4. It gives us 2.4, which is the number of moles of Na2O. This exercise on the right, it's required from you guys to do and send me the answers, okay, this one. Okay. Now let's move into another subject, which is the calculation of masses of substance. So we started with the moles, and now we are moving to the masses of a substance. It's easy. You have like a law that we will be using through the chapter, which is the number of moles of any substance equals the mass of a substance over the molar mass of the substance. Okay, so this is the equation, that the law that we are going to use. Okay, and I'll show you how to do that. Sometimes it gives you like number of moles of a substance, and you do the what we have already done in the previous slides, and then you calculate the mass. Okay, we'll see that in a bit. So number of moles of A gives us the number of moles of B. From mass of A gives us like how many moles of A, and for the B gives us the masses of B. Okay, and we got here for the this is the equation that I like talked about, the same law that we have already had in the previous slide, which is normality equals m over m capital, which is the mass over the molecular mass. So if I want to calculate or find out the mass, so we multiply the number of moles by the m, which is the molar mass of a substance. I'll show you everything in details in the upcoming examples.